Hello, young math Padawans. It's Mrs. Angel with your lesson for today on solving equations using the distributive property tool. Now, in this video, we are also going to be looking at using our properties of equality tool, but we are not going to be talking about our combining like terms. Now, to make this a little bit simpler, we're also only going to focus on distributive property with positive numbers. And then once we become comfortable with that, in a different video, we'll introduce distributive property with negatives. So grab your notes and let's get started. So as a quick reminder, the distributive property basically states that you're going to multiply everything inside of the group by what's outside to essentially free the constant. So looking at expression number 1, we have 4 times the group of x minus 5. We're going to multiply everything inside of the group by 4, and that will free our constant out of the group. So starting with x, 4 times x is just 4x, and 4 times a minus 5 becomes a minus 20. Now from here, you'll notice that the group is gone. My constant has become a minus 20, whereas it used to be a minus 5, but at least I now have 2 terms, and my constant is free. So the simplified version of expression number 1 is 4x minus 20. In expression number 2, we have something very similar, 5 times the group of 2x plus 1. Again, my constant is trapped inside of the group, so we're going to use distributive property to break it out. 5 times 2x, well 5 times 2 is 10, so 5 times 2x would be 10x. And 5 times a positive 1 would be a positive 5. So now that I have 2 terms and my constant is broken free out of the group, I know that this expression is fully simplified. Over in expression number 3, we're this time multiplying everything inside of the group by 3. 3 times 6 is 18, and 3 times a minus 5x, or a negative 5x, would become minus 15x. Again, my constant is free, and I have 2 terms, so I know that expression 3 is fully simplified. For our examples with solving, we're going to look at 2 different methods. In method 1, we're going to apply the distributive property first, then use our properties of equality. But in method 2, we're actually going to look at how you can solve the same equation without using distributive property and only using our properties of equality. Let's start with method 1. As always, I start by putting a line down the middle of the equal sign. And since the variable in this equation is on the left, I am not concerned with the 12 on the right. Now, I notice here that my constant, minus 5, is trapped inside of a group. So before I can do anything, I need that constant to be broken free. To do that, one of the tools I can use is called the distributive property, or DP for short. To do that, I would multiply everything inside the group by what's outside of the group, 4. 4 times x is 4x. And 4 times a minus 5 is a minus 20, and equals 12 is not affected. Now, essentially, I have a basic 2-step equation, and my constant is free, though it has become a minus 20, whereas before it was a minus 5. Either way, I know that I can apply APO, addition property of equality, to make my 0 term. If I add 20 to both sides, my new equation is 4x equals 32. And from here, to get 4 x's down to 1x, I would apply division property of equality, or DPO, and divide both sides by 4. 4x divided by 4 is 1x, and 32 divided by 4 is 8. Now, normally we would check at this point, but instead of checking, we're actually going to solve this equation again using a different order of steps. Again, I'm going to start the same way by putting a line down the middle of my equal sign. Now this time, instead of starting with the distributive property, I'm going to start by looking at this as a complex or tougher 2-step equation. Since this is essentially 4 times the group of x minus 5, I can think to myself, which property of equality do I use to undo multiplication? And the answer to that is division property of equality, or DPO. So if I were to look at this as I just want to get 4 times x minus 5 down to 1 times x minus 5, I would divide both sides by 4. Now what that does is create a big 1 out of the 4's, and now I'm left with whatever was inside of my group, which in this case was x minus 5. And 12 divided by 4 is 3. Now I have a simple two-step equation, x minus 5 equals 3. I would apply APO and add 5 to both sides to create that 0 term. And that leaves me with x equals 8. Since x is already by itself, I'm done and I don't have to apply any other tools. Since we ended up with x equals 8 using both methods, it doesn't matter which one you use. So, which one did you prefer? In equation 2, we're going to do the same thing. Method 1, distributive property first. Method 2, only properties of equality. Let's look at method 1. As always, I start by putting a line down the middle of my equal sign. And in this equation, I notice that the variable is on the right side of the equation, so I am not concerned with the other side. So let's start with our first method of applying the distributive property to get rid of the group and break our constant free. So 5 times 2x and 5 times a positive 1. 5 times 2x is 10x, and 5 times a positive 1 is a positive 5. And the negative 25 on the other side is not affected. Now that this is a simple two-step equation and my constant is broken free and has now become positive 5, I can go in and make a 0 term, which in this case I would apply subtraction to do, SPO. Subtract 5 from both sides. And my new equation is negative 30 equals 10x, since the 5 and the minus 5 became 0. To get 10x down to 1x, I would apply my division property of equality and divide both sides by 10. Negative 30 divided by 10 is negative 3, and 10x divided by 10 is 1x. So instead of checking, let's solve this same equation again using only properties of equality. Starting with my line down the middle of the equal sign, this time, instead of the distributive property, I'm going to start off with division, or depot, and divide both sides by 5 to create that big 1 factor. Again, the 5 and the divided by 5 creates 1, and then I'm left with whatever is inside of the group, which in this case is 2x plus 1. So going all the way through, negative 25 divided by 5 is negative 5, and 2x plus 1 is on the other side. Since this is a two-step equation, I'm now thinking get rid of the constant. To make 0 out of a plus 1, I would apply SPO, subtract 1 from both sides. Negative 5 minus 1 is negative 6, and I'm just left with 2x on the other side. To go from 2x's down to 1x, I would divide both sides by 2, again applying depot. And negative 6 divided by 2 is negative 3, 2x divided by 2 is 1x. Since we ended up with the same solution in both methods, it really doesn't matter which one you use. So which method do you prefer? Now it's your turn. You're going to solve this last equation on your own and check your solution when you're done. It's your choice whether you want to use the distributive property first or just use properties of equality. However, once you solve it one time, then you're going to solve it again using a different method. So if you did division property first, and the second time around, you're going to try distributive property. Over here, when you're done, you're going to explain what you did differently in the second time versus the first. Now, I'm not going to solve this equation with you. However, I will tell you that the solution to the equation is x equals 1. So no matter if you use division property or distributive property, you should end up with x equals 1. And if you do, you know that you did your work correctly. That's it for today's lesson on solving equations using distributive property, positives only. I'll see you next time.